Good morning everybody. Last time we had seen the transport number. The transport number we have seen that it is a fraction carried by the current. They are denoted by T plus and T minus. That we have seen. The transport number, we have seen that the transport number and the velocities of the ions, they are directly related. That means the fraction carried by the current is directly dependent on the speed of the ion, and therefore generally the T plus, it is written as V plus divided by V plus plus V minus. Similarly, T minus is written as V minus divided by V plus plus V minus. Obviously, as these are the fractions and they are depending on the speeds of the ions, therefore the T plus is equal to a fraction is nothing but the total speed of both of the ions. When the speed of the specific ion divided by the total speed, therefore you will get the fraction carried by the current, the fraction of current carried by the ion. So T plus is equal to V plus divided by V plus plus V minus. Similarly, T minus is equal to V minus divided by T plus plus, V plus plus V minus. So this is how the transport numbers are being related to the velocities. Now, in relation with the transport numbers, we are going to see the rule, that is the Hittov's rule. The Hittov's rule actually shows the relation between the transport number and the speeds of the ions. And for that purpose, the Hittov's rule, for that, the changes in the concentration takes place in the vicinity of the electrode. Obviously, what we are going to do is to determine the transport number, we have to see the change in concentration of both the ions, cations as well as the anions. Therefore, when the electricity is carried through the cell, the electrolytic cell, therefore it is observed that the changes in the concentrations are observed in the vicinity of the electrode, that means near the electrode. The change in a concentration is not observed in the center of the cell. Therefore, this concentration changes we are going to deal with, and the change in a concentration near the anode as well as the cathode, directly they are related to the velocities of the ions, and this is the basis of the Hittov's rule. Hittov have derived the relation between, or he has given the rule which shows the relation between the transport number and the velocities of ion. And to express this velocity, this Hittov's rule, he considered some arrangement, and the arrangement is somewhat like this. That means what he considered a cell. This is an electrolytic cell. That means a cell which constitutes of electrolytic solution, and in that electrolytic solution the electrodes are dipped. One of them is anode while the other is a cathode. Now this cell he considered to be divided into the three compartments. He considered two imaginary planes in the compartment. These are the two planes. And the electrolytic cell is divided into the three compartments: anode compartment, central compartment and the cathodic compartment. In these three compartments, the electrolytic cell is divided. Now, to give the rule, Hittov considered two cases. The first case, the electrolytic cell is being run for equal speeds of the ions. This is the first case, and the second case is for unequal speeds or unequal speed of ions. That means here V plus is equal to V minus, while here V plus is not equal to V minus. Now both of the case we are going to study. Alright? For that, the first case we will consider, that is for equal speeds of the ions. That means here the speed of the cation and speed of the anion is seen. While seeing the definitions of the transport number, we have seen that the ions, when they are of the same speed, they contribute same to the total electricity carried out. That means the fraction carried out by each ion will be same if the both of the ions are having similar speed. Let's see how. See, here the consideration is that we have considered an electrolytic cell. In that electrolytic cell, same number of the positive and the negative ions are considered. In that, in an anodic compartment and in cathodic compartment, we have considered 6 ions of each. That means 6 positive and the 6 negative. Here as well as here. While in the central compartment, 4 positive and 4 negative charges are there. As I have told you that the concentration changes taking place in the vicinity of the electrode. That means that the concentration of the cation or anion will change in these 2 compartments only. There will be no change in the concentration of the central compartment. Now what we are going to do is, we are going to provide 4 Faradays of electricity to this electrolytic cell. How many? 4 Faradays. 4 Faradays of electricity is carried out through this cell. That means that 4 equivalents, 4 Faradays of electricity is carried out. That means 4 equivalents of each ion will migrate. Right? Now, when you provide this much of electricity, therefore what happens? 4 negative anions, that means 4 ions, they leave their electrons and get deposited on the anode. While 4 cations, they take the electrons from cathode and get deposited onto the cathode. Therefore, what is remaining now? 6 plus charges as it is, only 2 negative are remaining. Central compartment is as it is. As soon as you pass the 4 Faradays of electricity through the cell, therefore, first what will happen? The 4 equivalents of the anions will leave their electrons and get deposited on the anode. While in the cathodic compartment, 4 positive cations takes the electron from cathode and get deposited on the cathode. Here only 2 positive are remaining and 6 negative. So this is the stage first. Alright, when this migration is done, while this migration is happening, here as the 2 ions are having same speed, right? Therefore, both of the ions will contribute same to the total electricity carried out, right? Therefore, 4 Faradays electricity is carried out. That means 2 will be carried out by the cations, while 2 will be carried out by anions. Now here therefore, 2 cations migrate from left to the right, while 2 anions migrate from right to the left. Obviously, positive cations, they will migrate towards the cathode, while the anions will migrate towards the anode. Therefore, during this migration, these 2 positive charges will go first to the central compartment, and from central compartment they will migrate to the cathode. Similarly here, these 2 negative charges or 2 negative anions, they will migrate to the central compartment first and then to the anode compartment. Exactly two ions we have transported or migrated. Why? Because here both the ions are having same speed. Hence both of them will carry same electricity. Total is 4. Therefore 2 will be carried out by anions, 2 will be carried out by cations. And 2 cations therefore will move to the center, and from center they will move to the cathode. While the 2 anions move from cathode compartment to the central compartment, and from central compartment to the anode compartment. Therefore, what is the situation? The situation is the 2 will migrate here, and from here again here. So, 2, here how many remaining? 4. 1, 2, 3, 4. 2 have migrated here. So total 6, and 2 again will migrate here. So these 2 and 2 more. So this is stage first, this is stage second, and this is stage third. This is the result of passing 4 Faradays of electricity. See, again I will explain you. What we have done? We have taken an electrolytic cell. In that electrolytic cell, we have considered same number of positive and the negative charges. Then we divide the cell in 3 compartments with these 2 plates. The 3 compartments are anode, center and cathode. In the anode and the cathode compartment, same negative and positive charges are there, that is 6 each. And in the center, 4 positive and 4 negative. Then when we pass 4 Faradays of electricity, therefore, in the anode compartment, 4 anions, they leave their electrons and get deposited on the anode. Similarly, in the cathode compartment, 4 positive charges or 4 cations, they take up the electrons from the cathode and get deposited on the cathode. This is the stage first. After the stage first, while this migration is taking place, 2 Faradays of electricity is carried by the cations from anode to cathode, and 2 Faradays of electricity is carried due to the migration of the anions from cathode to anode. So 2 cations move first to the center, and from center to the cathode again. Here also 2 anions migrate first to the center and from center to here. So this is the result. 4 positive, 4 negative, here also 4 positive, 4 negative, 4 positive, 4 negative. Now, see the changes in the concentration. The central compartment, initially it was having 4 each, now also 4 each. That means there is no change in the concentration of the central compartment. Let's see for the anode and cathode. In the cathode, how many positive are there? 6. Now 4. Similarly, negative are also 4. Similarly, in the cathode, here also 2 cations are lost and 2 anions are lost. That means the loss in the cations and the anions in both anode and cathode compartment are exactly same. This is because V plus is equal to V minus A. Correct? Therefore, V plus is equal to V minus A. Let's consider the second case now. For unequal speeds of the ions. For unequal speeds of the ions. Again, the same cell we have considered. Similar number of negative and the positive charges are there. Cathode contains 6 of each, as well as anode contains 6 of each. But here now, the case is that V plus is 1 by 3 of V minus. That means V minus is equal to thrice of V plus. What this means? This means that the anions are having the speed 3 times that of cations. The anions are having the speed 3 times than that of the cation. That means V minus is moving with 3 times more speed than the cation. Therefore, in this case, let's see what happens. Again, what we have done, 4 Faradays of electricity is passed through the cell. Therefore, in the first stage, initially what will happen? The similar case will be here. in the stage first will be exactly same. That is, 4 equivalents of negative ion will leave their electron and will deposit on anode. Similarly here, 4 equivalents of cations take up the electron and will deposit onto the cathode. While this migration is done, this deposition is done, now V minus is thrice of V plus. That means here the contribution of anion in the total electricity is thrice of the cation, right? That means that V minus is having more speed, thrice of speed than the positive ion. Therefore, see, only 2 negatives are remaining. The central compartment is as it is, and the 2 positive and 6 negatives are remaining. As the negative ions are having more speed, thrice of them. Therefore, 3 equivalent, total is 4 Faradays. From that, 3 equivalents of electricity will be carried out by the negative ions due to their mole speed. So therefore, here 3 equivalents of anion move from cathode compartment to the anode, to the central, and then to the anode. While V plus, that means the cation, is having a speed 1/3 of V minus. That means it will contribute only 1 equivalent of electricity. Hence, therefore, 1 cation will move to the center first, and from center it will move to the cathode. Therefore, let's see what is the situation. 5 are there, right? These 2 and 3 have become here. From here to here, here to here. So total how many charges are negative now? 5. The central compartment is the positive. It goes to central first and from central to here. That means there is no change in concentration in the central. Here 1 more has came, so 3 positive and 3 these remaining negative. Now see the concentration change in the compartments. The central compartment, as we have seen, there is no change in the concentration. The change in a concentration that takes place in the anode and the cathode due to migration of cation and negative ion, that is the anion, and has takes place. And therefore the change in concentration, we observe that the change in a concentration of the cathode compartment is thrice to that of the anode compartment. That means cathode compartment मध्ये झालेला जो काही concentration मधला change आहे हा anode compartment मध्ये झालेल्या concentration changeच्या 3 पटीने change झाला. As the speed is, ज्या प्रमाणात त्यांचा स्पीड आहे त्याच प्रमाणात त्यांच्या कॉन्सन्ट्रेशन मध्ये बदल झालेला आहे. And therefore the Hittorf's rule is such that loss of the cations in anode compartment due to migration divided by loss of anions in cathode compartment due to migration is equal to V plus divided by V minus, which is equal to T plus divided by T minus. This is what is the Hittorf's rule. And from the changes which are occurring in these 2 cases, from those 2 cases, this rule is written. Loss of the cations in anode compartment due to migration. Here, how many cations have migrated? Only 1 cation has migrated, right? divided by the loss of anion in cathode compartment due to migration. Here 3 cations have lost. That means this ratio for this case will be obviously 1 by 3. And that is nothing but V plus divided by V minus is equal to 1 by 3. And that we have seen here. Right? So this is what is the rule, and this is equal to T plus divided by T minus. So here the change in a concentration in the compartments is related to their velocities, and on the velocities the transport numbers are dependent. So therefore from this rule we can calculate the transport numbers of the ions. From this rule we can calculate the transport numbers of the ion, and therefore we are going to see the Hittorf's method to determine the transport numbers. I will again tell you the rule. This is the Hittorf's rule. The loss of the cations in the anode compartment due to migration divided by the loss of the anions due to migration in the cathode compartment is equal to V plus divided by V minus, which is equal to T plus divided by T minus. That means simply we can write this as V plus divided by V minus is equal to T plus divided by T minus. This is what is the Hittorf's rule. And from this rule we can calculate the transport numbers of the ions. Therefore we are going to see the methods to calculate the transport numbers of the ions. We have two methods, the moving boundary method and Hittorf's method. In that we will see first Hittorf's method. Now what the Hittorf's method is, from this method obviously the transport numbers are being determined, and for Hittorf's method this apparatus is being used. We can see here an electrolytic cell arranged in this pattern is used here. Here, as we had seen in the rule, the 3 compartments were divided. The similar here is that cathode compartment, anode compartment and central compartment is divided. This is a cell A. The electrolytic cell A is this, and this is divided into the 3 compartments. In the 3 compartments, the electrolytic solution is being filled here in all the compartments. These are the electrodes, and to the electrodes milliammeter is here, which is joined in a series with the circuit. Here the battery is there to provide the current. Here is a milliammeter. What milliammeter does? Actually what we can do is, from the milliammeter we can adjust the desired current that should flow through the circuit. Milliammeter will show the current, so we can adjust the desired current that will flow through this electrolytic cell. Now to this cell a coulometer is adjusted, or coulometer is connected in the series. Now what is a coulometer? The coulometer is used to measure the exact electricity that has passed through the circuit. सर्किट मधून एक्झॅक्टली किती इलेक्ट्रिसिटी पास झाली हे मोजण्यासाठी किलोमीटर वापरतात. नाउ व्हाट इज अ किलोमीटर? देयरफॉर द किलोमीटर इज consist of the platinum dish, and in that platinum dish a purified silver nitrate solution is used, and the pure silver rod is dipped in it. The silver rod dipped, it acts as the anode, while the platinum dish, the platinum that consists of or that works as the cathode there. And this coulometer is useful for precise work. When we pass the certain amount of electricity through the cell, same amount of electricity is passed through the coulometer. Therefore, what happens here? When you pass the electricity, the silver is deposited on the platinum dish. Therefore, if we take the weight of that platinum dish before and after, Therefore, increase in the weight of the platinum dish can be calculated, and from that, how many equivalents of the silver have deposited, that we can calculate, and the equivalents of the silver deposited is equal to the equivalents of the Faraday of electricity has passed through the cell. So this coulometer is used to determine the exact amount of electricity or equivalents of electricity that have passed through the circuit. Here these two are the electrodes. The electrode, they are consisting of platinum, but sometimes the anode which is used here, that may be of the silver or copper. The attackable electrode can be used. Alright, what this attackable and non-attackable is, we are going to see. So this is what is the setup for the Hittorf's method to determine the transport number. Now, how this transport numbers are being determined from this Hittorf's method, that we are going to see. Now there are two cases. First we will see. See here, when you pass the electricity, the changes in the concentration of both of these compartment happens. Generally what is done, the solution of the anode compartment is a drain from here, and the weight of that solution is taken. The weight of the solution before and after they are taken, and from that we can do the calculations for transport number. When you pass the electricity, the change in concentration of both of this compartment will be there. The central compartment, no changes will occur there. So to calculate the change in concentration of the anode compartment, the solution after the electrolysis is taken out or a drain out, and that solution weight is taken. Therefore, the weight of anodic solution taken out, if it is considered to be X, anodic solution it is, the weight of electrolyte, this part is after the electrolysis. So weight of the anodic solution, total solution, that means with water, dissolved part and all, weight of the anodic solution is X. In that, the weight of electrolyte, if it is Y. Therefore, simply the weight of water will be X minus Y grams. Now, equivalent of electricity passed. That means here in a coulometer. So what for that, what we can do? Will before the electrolysis, we will weight this finely clear, clean dish, platinum dish. We will weight it. In that we will pour the silver nitrate solution and a pure silver rod, and during this electrolysis process, here also electrolysis takes place. The amount of electricity passed through this circuit is the same amount of electricity passed through this coulometer. Therefore, after the electrolysis, when we take or when we calculate the increase in weight of the platinum dish, will get the amount of the silver deposited. Alright, and if it is W, weight of the silver deposited, if it is W, therefore how the equivalents are calculated? Divided by its atomic weight. This will give you, let's agree, D equivalents. This much of electricity is passed or this much of equivalents are deposited. So this part is after the electrolysis or after passing the electric current. One more thing has to be considered. Before passing the electric current or before the electrolysis, Z gram is the amount of electrolyte or weight of electrolyte taken. Now in this case, now here two cases are possible. The first is when attackable anode is used. Like silver or copper electrode is used, copper with copper sulfate or silver with silver nitrate. If such type of electrode used, so in this case we are going to calculate the transport number. Now see, during the electrolysis process, the anions, that means the negative ion, will move from cathode to the anode, while the positive ion from anode to cathode will migrate. Therefore, we want to calculate the increase in concentration of the anode compartment. See, if I consider that here 30 equivalents were present initially of the silver, as NO3 minus ions that will migrate, that means anions will migrate from cathode compartment to the central and central to anode. NO3 minus ion, when they are migrated to anode, they react with this silver electrode and they forms the solution AgNO3. That means here already AgNO3 is present. Due to migration of NO3 minus ions here, more formation of silver nitrate takes place. That means the concentration of silver nitrate will increase in this compartment. Correct? The concentration, see, silver ion plus ions, they dissolve from the rod, the electrode that you have taken, that dissolves for the Ag plus and one electron, and that Ag plus that combines with the NO3 minus ion migrated from cathode to anode, and therefore there is a formation of electrolyte again, which is already present. So concentration of the silver nitrate which is present in anode compartment, that increases. For example, if 30 equivalents were present and in that 20 have migrated, so total 50 will be formed, right? But here the migration is not only from cathode to anode, the migration is also taking place from anode to cathode. So some of the equivalents of the silver will be, इथून Ag plus ion काय होणार आहे, Ag plus ion सेंटर मध्ये येतील, सेंटर मधून इकडे येणार, म्हणजे काही ions परत इकडे मायग्रेट होणार आहे. So therefore, if I consider this is a 10 equivalent, सुरुवातीला इथे Ag plus चे 30 equivalent होते, इकडून इकडे 20 NO3 minus equivalent ट्रान्सपोर्ट झाल्यामुळे पुन्हा त्याच्यात 20 इक्विव्हॅलेंट Ag+ चे वाढले, पण त्याच्यातून काही Ag+ हे इकडे पुन्हा इकडे सुद्धा मायग्रेट होणार आहे, म्हणजे टोटल तुमचं कॉन्सन्ट्रेशन किती होणार, 40. सी दॅटफोर the negative ions migrated to the anode. Negative ions migrated to anode will increase the concentration. Will increase the concentration which is equal to का सुरुवातीला याच्यामध्ये किती होते तर Z ग्राम्स आपण कन्सिडर केले होते, बरोबर, आणि जे काही इन्क्रीज झालेले आहे that is Z minus Y grams. This is increase in the concentration, that means due to the negative ions. आता याचे जर इक्विव्हॅलेंट्स काढायचे असतील तर ऑब्वियसली तुमचे जे काही इलेक्ट्रोलाइट आहे त्याचं मॉलिक्युलर वेट घ्यायचं, त्याच्यामध्ये सिल्वर प्लस किती आहे त्याच्यावरून याच्यातले इक्विव्हॅलेंट्स तुम्हाला काढता येतील. So equivalents migrated to anode is equal to E equivalence. म्हणजे मी याच्यासाठी काय केलं, अगोदर याच्या वेट मध्ये जेवढा इन्क्रीज झालाय कोणाच्या इलेक्ट्रोलाइटचे जे काही वेट आहे अगोदर त्याच्यामधला एक्झॅक्ट इन्क्रीज झाला. सुरुवातीला एक्झॅक्ट झेड होते, आपण जेव्हा सोल्युशनचं वेट केलं ते वाय झालं, बरोबर. म्हणजे इन्क्रीज झालेलं वेट किती तुमचं, तर इथे सॉरी वाय मायनस झेड पाहिजे, वाय मायनस झेड ग्रॅम एवढं इलेक्ट्रोलाइटचं वेट इन्क्रीज झालं. आणि त्याचे इक्विव्हॅलंट्स काढायचे असतील तर त्याला त्याच्या जे काही तुमचं इलेक्ट्रोलाइट आहे त्या इलेक्ट्रोलाइट मध्ये तुमचं पॉझिटिव्ह आयन किती आणि त्या पॉझिटिव्ह आयनच्या रिलेशन वरून आपल्याला इक्विव्हॅलंट्स काढता येते. सो दीज आर द ई इक्विव्हॅलंट्स. ना पण हे कसे झाले, फक्त हे मायग्रेशन आपण कन्सिडर केले कॅथोड टू एनोड, राईट. पण काही पॉझिटिव्ह आयन्स हे पुन्हा तुमच्या एनोड कंपार्टमेंट मधून कॅथोड कंपार्टमेंट मध्ये आलेले आहेत. म्हणजे याच्यातून पुन्हा काय होणार, काही अमाउंट हे डिक्रीज होणार आहे. सो फॉल इन अ कॉन्सन्ट्रेशन इन एनोड कंपार्टमेंट इज इक्वल टू आता इथे पहा, तुमची जेवढी काही इलेक्ट्रिसिटी मायग्रेट झाली आहे टोटल ती म्हणजे डी इक्विव्हॅलंट आहे, बरोबर. निगेटिव्ह आयननी कॅरी केलेली जी काही तुमचे इलेक्ट्रिसिटी ती म्हणजे ई इक्विव्हॅलंट. कोणत्या आयननी, फक्त निगेटिव्ह आयन. मला जर पॉझिटिव्ह आयनची काढायची असेल तर ऑब्व्हियसली पहा इथे जी काही इक्विव्हॅलंट्स ऑफ इलेक्ट्रिसिटी पास झाली ती म्हणजे कॅटायन आणि एनायन या दोन्हींनी मिळून कॅरी केली. त्याच्यातली आपण एनायनची काढली, मग केटायनची म्हणजे डी मायनस ई, म्हणजे हे जे केटायन इकडून इकडे मायग्रेट झाले ते म्हणजे डी मायनस ई. हे झाले तुमचे फॉल इन अ कॉन्सन्ट्रेशन. नाउ देअरफॉर टी प्लस इज इक्वल टू, आता हे पहा, fall in concentration in the anode compartment is D minus E. That means the equivalence of electricity carried by the positive charges, that is nothing but D minus E. And if I want to calculate T plus, म्हणजे मला जर हा फ्रॅक्शन काढायचा असेल तर याला टोटल पॉझिटिव्ह आणि निगेटिव्हली मिळून कॅरी केलेली जी इलेक्ट्रिसिटी आहे त्यांनी जर डिवाइड केलं, so this will give you the transport number. This is the total amount of the electricity carried out, while this is only the amount of electricity that is carried by the cations. Therefore D minus E divided by D, this is the fraction of the current or the electricity carried by positive ion. And therefore T minus जर काढायचं असेल तर we know that T plus T minus is equal to 1. Therefore T minus is equal to 1 minus T plus. Therefore 1 minus D minus E divided by T. So this is 1 minus multiplied with this D here, D minus D plus E divided by T. So this is E divided by T. So these are the transport number T plus and T minus. Alright. Now this was for the attackable electrode. हे पहा, अटॅकेबल इलेक्ट्रोड मध्ये काय होतं, इथे हा जो काही इलेक्ट्रोड आहे हा अटॅकेबल असल्यामुळे इकडून येणारे निगेटिव्ह आयन्स जे आहेत त्याच्यासोबत तो काय करतो, इथे जे काही तुमचं इलेक्ट्रोलाइट आहे ते काही इलेक्ट्रोलाइट तयार करतो. इथे ऑलरेडी सिल्वर नायट्रेट आहे, हा सिल्वर रॉड याच्यातून सिल्वर प्लस आणि इलेक्ट्रॉन तयार होतात आणि इकडून जाणारे जे काही NO3 मायनस आयन आहेत त्या सिल्वर प्लस सोबत काय तयार करतात, पुन्हा ते इलेक्ट्रोलाइट तयार करतात, त्याच्यामुळे इथे कॉन्सन्ट्रेशन वाढतं, बरोबर. मग आपण अगोदर काय केलं की जे काही कॉन्सन्ट्रेशन इन्क्रीज झालंय ते इन्क्रीज झालेलं आपण अगोदर कॉन्सन्ट्रेशन काढून घेतलं, बरोबर. इन्क्रीज झालेलं जे काही कॉन्सन्ट्रेशन आहे त्या कॉन्सन्ट्रेशनचे आपण इक्विव्हॅलंट्स काढले. त्या इक्विव्हॅलंट्स मधून हे जे काही कॉन्सन्ट्रेशन इन्क्रीज झाले हे सगळं जसंच्या तसंच नाही झालं, त्याच्यातून काही पॉझिटिव्ह आयन कॅथोडकडे मायग्रेट झाले, म्हणजे आपल्याला पुन्हा मायग्रेट झालेलं कॉन्सन्ट्रेशन मायनस करावं लागेल. मग हे काढण्यासाठी आपण काय केलं, तर टोटल जेवढी इक्विव्हॅलंट्स मायग्रेट झालेले पॉझिटिव्ह आणि निगेटिव्ह मिळून त्याच्यातून आपण फक्त जे काही निगेटिव्ह आयननी त्यांचे इक्विव्हॅलंट मायनस केले. मग हे झालं फॉल इन कॉन्सन्ट्रेशन. आता हे जे काही कॉन्सन्ट्रेशन फॉल झाले म्हणजे थोडक्यात ही अमाउंट्स ऑफ इक्विव्हॅलंट हॅव मायग्रेटेड बाय दी केटायन, आणि म्हणून टी प्लस काढण्यासाठी द अमाउंट ऑफ or the equivalents of the cations migrated divided by the total number of the equivalents migrated, positive as well as negative. So this gives you T plus. T minus, so 1 minus T plus you get here. Now the non-attackable electrode we are going to see. म्हणजे जेव्हा तुमचा एनोड जो आहे तो प्लॅटिनम सारख्या मटेरियलचा जर बनलेला असेल तर and that platinum electrode is a non-attackable. Non-attackable म्हणजे काय, तर इथून जे काही NO3 मायनस आयन इथे मूव्ह होणार आहे किंवा मायग्रेट होणार आहे ते NO3 मायनस आयन पुन्हा आता इलेक्ट्रोलाइट तयार करू शकणार नाही, कारण हा इलेक्ट्रोड प्लॅटिनमचा आहे. याच्यातून Ag प्लस हे पाहिजे अशी रिएक्शन होत असते जर तुमचा सिल्वर इलेक्ट्रोड असेल तर. पण हा जर प्लॅटिनम असेल तर सिल्वर प्लस तयारच होणार नाही, मग इथून येणारे जे NO3 मायनस आयन आहे ते AgNO3 तयार करू शकत नाही. सो हिअर फक्त आता इथे काय होणार, इथून काही पॉझिटिव्ह आयन्स मात्र मायग्रेट होणार आहेत. Ag प्लस आयन तुमच्या सोल्युशन मध्ये ते आयन्स मात्र इकडे मूव्ह होतील, त्याच्यामुळे इथल्या AgNO3 चं कॉन्सन्ट्रेशन आता मात्र फक्त डिक्रीजच होणार. अटॅकेबल मध्ये कसं होतं, सुरुवातीला इन्क्रीज काहीतरी कॉन्सन्ट्रेशन इन्क्रीज होतं आणि मग त्याच्यातून थोडंसं डिक्रीज होतं ड्यू टू द मायग्रेशन ऑफ केटायन. इथे मात्र NO3 मायनस आयन इकडे ट्रान्सपोर्ट झाल्यामुळे AgNO3 तयार होत नाही, त्याच्यामुळे AgNO3 चं कॉन्सन्ट्रेशन इन्क्रीज होणार नाही. फक्त याच्यातले Ag प्लस इकडून इकडे म्हणजे एनोड कडून कॅथोड कडे मात्र मूव्ह झाल्यामुळे कॉन्सन्ट्रेशन जे सुरुवातीला होतं त्याचं कॉन्सन्ट्रेशन डिक्रीज होणार आहे. हेन्स फॉल इन कॉन्सन्ट्रेशन ऑफ or concentration in anode आता हे जे काही कॉन्सन्ट्रेशन आहे ते का डिक्रीज होत आहे, ड्यू टू मायग्रेशन ऑफ केटायन्स. that is equal to ऑब्वियसली Z म्हणजे काय आहे, सुरुवातीला इलेक्ट्रोलाइटचं असणारं वेट. Y म्हणजे काय, एनोडिक सोल्युशन काढून घेतल्यानंतरच येणारं वेट ते म्हणजे Y, आणि त्याचे इक्विव्हॅलंट्स काढले की ते झाले तुमचे E इक्विव्हॅलंट्स. Alright, therefore here simply E plus will be equal to, this is the equivalence carried by the cations or due to the migration of cations, therefore E divided by total equivalence carried of the cation as well as Ni, therefore T plus is equal to E divided by D and T minus is equal to 1 minus T plus, that means 1 minus E divided by D. So this is what is the T plus and T minus in case of non-attackable electrodes. While these are in case of attackable electrodes. This is the T minus. It's little bit complicated, but if you consider the numbers, it is easy to understand. See, when the electrode is non-attackable, when it is a platinum, therefore consider that 30 equivalents of the Ag plus are present here, and if from this 30 only 10 migrated, therefore how many will remain here, 20. That means to calculate T plus, how we will calculate T plus is equal to 10 divided by इथे जे काही इक्विव्हॅलंट्स कॅरी झाले इफ दे आर 30 सो सिम्पली t प्लस इथे जे काही टोटल इक्विव्हॅलंट आपल्याला ट्रान्सपोर्ट झालेले मिळतील that number if you divide you will get t plus. alright, but in case of attackable electrode आपल्याला इन्क्रीज झालेलं कॉन्सन्ट्रेशन आणि त्याच्यानंतर पुन्हा केटायन मायग्रेट झाल्यामुळे झालेलं तुमचं फॉलिंग कॉन्सन्ट्रेशन हे दोन्हीही कॅल्क्युलेट करून t प्लस आणि t मायनस काढावे लागतात.